seconds behind or your voice is 2 seconds behind what you're doing on the screen.
Oh, really?
Yeah.
I wonder if that's the actual recording or if that is like maybe when it is streaming that, like if you have you tried refreshing it a couple times to see if it fixes? No, it didn't, huh. So let's see, I'm doing it on the screen and then I'm saying it, or I'm saying it, then I'm doing it.
It happens on the screen in 2 seconds that you're talking.
Oh, see, that's worse. Seems like it'd be better if you hear me say it and then see it on the screen. Is that right? Maybe not. Maybe seeing it. Maybe kind of seeing what I'm about to talk about than actually. I'm sure it's gold regardless.
I think it's the other way. I think you do it. No, it's not you talk about it.
I think I would want you to explain what you're doing and then actually see you do it. I think that'd be.
All right, somebody explain to me what I'm doing. What are we doing? Oh yeah, text stuff. All right, so did we test all this? I kind of remember scrambling right at the end of class, finishing it. What was find text the last thing we did? Oh, finish this. See bug in line 62. Haha, little note. Okay, so find text. It takes in a string, and what we're looking for is we're counting the number of occurrences of that text in our paragraph or whatever. That's what we're doing. Okay. So we're asking. So the string it's taking in. This guy is our paragraph, our input text that we entered in earlier. Okay. Then we're going to ask what sequence should I look for, and you're going to enter in your sequence. Now what we're doing is we're going to go through our code, and we're looking for that sequence. All right, and we're going to use the index of function of the string class. And what does index of do? Remind me about this this method. What does the index of method do? Go ahead.
It looks at certain strings index or s.index of.
Yep. So it looks at the calling string. So this guy, whatever he holds.
Yeah, and then it takes that number and looks at that bucket, I guess, and it looks at what char is there.
Um, yeah, that's char at. So index of is the inverse of that. What does index of do?
It looks at, say you have like A, it'll tell you what bucket A is first found.
Yep, exactly. So index of takes in a char, or in this case, we're passing it a string. There's a couple of versions of index of. And we pass it what we're looking for, in this case, a string, and it returns for us the position, the index, in the calling string. So in this case, the position in S, where whatever's inside of sequence first is found. What if it's not found? What does it return? It's probably the most important part of index of, is understanding what happens if it doesn't find something. Nope. -1. Yeah, because 0 would be a legal index, right? The sequence you're looking for might be right at the beginning of the string. Okay, so -1 is what it returns if it can't find it. All right, so what are we going to do? We're going to search for it at least once. That while we're putting this thing in a do while. So we're going to go ahead and store inside of a variable called pos the position, the first position inside of S, where sequence is found. So there's several versions of index of. So let's actually go to the documentation here quickly. Java.sun.com. We're looking at the string class. That's in java.lang. Here's string. And we'll scroll down. Here's our methods that are in here. And here is index of. So we have 1, 2, 3, 4 versions of index of. I don't remember if I taught this concept or not. Do you know what it's called when we have more than one method with the same name with a different number and or type of parameter? Is that vocabulary word in your head somewhere? What is it? I don't think we've covered. I don't know we covered it in here. I think we maybe covered it last semester. Funny word starts with a P. And ends in an ism. Polymorphism. Okay, it's polymorphism. Let's throw that on a slide. So, it starts with a P, ends in an ism. There's an ollie in there. It kind of sounds like polymorphism. All right. Polymorphism. So this is multiple methods with the same name, but a different number and or type of parameters. And really, you could, if you wanted to be more specific about it, you would replace name with the same definition. So that's return type and name. Actually, no, that's not true. They're treated the same if they have the even different return types, because you're not required to use return types. So this is accurate. So multiple methods that have the exact same name, but they take in a different number and or type of parameters. And it's important to understand that it has nothing to do with the name of the parameters. So my method int A would be identical to my method int B. Okay? That's an error. That's not an example of polymorphism. Those two methods have the same name and have the same number and type of parameters. Okay? Java does not care what you name this integer versus this integer. That's just how we use it inside the scope of that method. That makes sense? But this would be an example of polymorphism. Two methods that have the same name but have a different number and or type of parameter. So if I want to take it a step further, I could say char C here. So this one and this one, the second two, both have one parameter, but one of them takes an int, the other one takes a char. Therefore, these are distinguishable methods. We can tell them apart from each other, and this would be an accurate example of polymorphism. Make sense? There's a similar concept known as method overloading, okay, or overriding a method. So we'll talk about this when we get into inheritance, just so I might just do a quick thing. Let's call this method overloading. This guy typically refers to inheritance where we have a method given to us and decide to rewrite that method with different logic. All right, and we haven't really dealt with inheritance yet. We will relatively soon, but sometimes overloading a method can be confused with polymorphism. The reality is it doesn't really matter, those words. I kind of like polymorphism because it's kind of fun to say. But it's more important for us to understand the concept that when we're looking through documentation, we may find multiple methods that have the same name, but they operate on a different number and or type of parameters to help us solve problems. And index of is a good example of this because we're going to use one of the, let's say, less common index of versions here. So we have one version of index of that just takes a char, and this guy returns the index within the string that called it of the first occurrence of the specified character. So that's kind of the definition he gave, right? The position in the string where we first find that char. And that guy is the char equivalent of this guy. So here's one that takes a char, here's one that takes a string. Okay? The string one returns in the calling string the position where the first occurrence of that string is found. We called it sequence in our method. All right, so if we're searching for A, B, and C, got to duct tape it. You get that? I've seen a new commercial for Gorilla Tape. Have you seen that one? This father and son are trying to duct tape the bumper onto a car, and they say, "Oh, that's not going anywhere." Then it just falls off, and then a gorilla comes in and holds the bumper up and wraps it in Gorilla Tape, and it stays. So we need Gorilla Tape for this, with a Gorilla installer probably. You know, I was actually thinking that. So I just didn't want to say it because I figured it'd be rude. All right. So this version of index of and this version of index of are equivalents to each other. You have to tape this guy down.
I say just leave it up.
I might end up leaving. If that happens again, we'll just leave it up because we can probably see it well enough on the screen. All right.
Wait for it.
Ish, yeah. So these two do the same thing, just the second guy operates on a string, which allows us to look for a sequence within a string, a substring within a string, rather than just a single char. Okay? But then we have an alternate version of these two guys, similar to them. You want to leave it like this or just put it all the way up?
Leave it.
Leave it? It's fine? Okay. We can see. Oh, you know what? What if I'm pointing to it? We're going to call that good enough. With a nice string just laying there. So I'll just get it swinging. So now it just underlines that sentence. All right. Yeah, so these other two versions of these guys, they work similarly to the first one. Well, they work identically to each other. One of them takes in a char, one of them takes in a string, but it begins the search of your string from a different starting point. These first two that we looked at always start at bucket 0 in our string for the search. These other two, they start at position from index, where we want them to begin their search. So it'll show us it'll return the first position within the string, starting from bucket whatever, where CH or STR was first found. That make sense? So it allows us to kind of jump around in the string and kind of skip over the first one we found. So we're going to be using this version of the guy, where we pass it the string we're looking for and the place we want it to begin our search, because we're trying to count the number of occurrences that happen with this guy. All right, so once we find the first occurrence at bucket 3, for example, we want to look at the next occurrence that starts at bucket 3 plus the length of this string. That way it continues to search. Actually, you could even leave the length of the string off, because you could, yeah, I think that would be legitimate. So you can leave the length of the string off and just add 1 to this, because it won't find that substring a second time. But you could actually have the substring in there multiple times in a row. So if it's SSSS and you're looking for SS, you'll find it the first 2 S's, then the second S and the third S, then the third S and the fourth S. You'll find it in that same little substring multiple times. So you really just want to increment by 1. But it'll allow us to find the position of the first SS, then the position of the second SS, skipping past the position we already found, so on and so forth, okay? So this is as if we walked into Home Depot, bought a tool, read the instructions, and now we know how to use that tool, all right? This guy is an instance method, doesn't have static in front of it. We call it using an instance of the class on which it was defined. This guy's a string method, so we say s dot index of, and we'll talk more about that instance versus class method stuff as we start getting into objects. All right, so back here, we read in the sequence we're looking for. We start our position. This is where we found something, off at 0 for right now. And then we have a variable called count that we're using to count how many times we found this dude. We're going to search at least once, so we're going to search in S for the index of this sequence starting at bucket 0, the very first position in our string. okay, because that's what we started pause off at. So now we're going to store in pause whatever's returned by this call. Whatever's returned by our hunt inside of S for the character sequence stored in SEQ, starting at bucket pause, which this time through is 0. All right? As long as pause is not equal to -1, which means it was found somewhere in there, right? Because we said that it returns a -1 if it didn't find it. So as long as pause is not equal to -1, that means we found at least one occurrence of our sequence. So we'll add 1 to count. Then, and just as a quick little verbal quiz, what's the difference between count plus plus and plus plus count? We won't have both of those lines in there. I'm going to remove one of them. But what is the difference between having the plus plus coming after the variable name versus the plus plus coming before the variable name? This is something we talked about a while ago. It's also something I encouraged you not to always put these on individual lines like we have here, as opposed to int num is equal to count plus plus, int num2 is equal to plus plus count. So I guess what I'm really asking is, what value does num hold and what value does num2 hold here, and why? Go ahead.
I think the first one would add 1 to the value of counts. Then the second num will add, probably multiply by 2, like double the number.
Okay. No, both of these guys will add 1 to count. Both of them will add 1 to count. My question is what will end up in num and num2 after each of these lines? So if I were to print out num here and then print out num2 on the next line, what value would I see? And here we can assume that, well, count started off at 0, but here I'll just say count is equal to 5. I'll give you a starting example there. So if count starts off at as 5, what will me printing out num right here print out? And what will me printing out num2 right there print out? What value? We did talk about this, right? Plus plus. You don't remember? I'd be very surprised if we didn't. It was last semester? Well, everybody's forgotten everything from that. Okay, yeah, it doesn't look like it's in this slide set. All right, well, let me just talk about it.
I would agree with what we did last semester.
So you vaguely remember the concept. Okay. So it's not completely foreign, but it's off the reservation enough that it's worth looking at again. All right. When the plus plus comes after, this guy right here boils down to, in the moment, the original value of count. So num here would be equal to 5. But then count would go to 6. So ultimately, count would have 1 added to it and would modify. So it would be, a 5 would become a 6 in count. But because I had the plus plus after the count, I'm in effect saying set num equal to count and then increment count. This one down here, I'm saying increment count first and then set the value in num2. Make sense? So the difference between these guys is when the add 1 actually occurs. My argument is now, so I just explained to you it's not a horrifically hard concept to remember, right? But might that be one of those things, especially as a beginner intermediate programmer goes, where that might confuse you, you might forget exactly how it works or something like that? Certainly possible, right? So something you'll sometimes see when you're doing your Google stuff is you'll see somebody do something like, print count plus plus or print ++ count. Okay. In effect, these guys are trying to get away with doing something that could easily be done in 2 lines with 1 line. Okay, they're saying, hey, I want to print out the new value of count here because this will increment count first, making count 1 greater than it used to be. More bulbs. See that message just came up? More bulbs are being delivered. This is ridiculous. This is just getting out of hand. Hundreds of dollars in bulbs. But they change colors. We had to wait for this model to come out, though. The previous ones couldn't do green. Yeah, these are the Hue 2.1. Not even on the shelf yet. That's why you got to know somebody who works at Best Buy so they can get them from the back. It's ridiculous.
So I bet you not the new models are on sale, aren't they?
Oh, is that why? Are they on sale now?
No,
2.0?
Since they came out with the
Oh.
2.1.
Yeah, I don't know. It's above my pay grade. All right, so what you'll see sometimes when you do your Google searches for stuff is you'll see programmers trying to incorporate something that could very easily just be done in 2 lines to accomplish what they want to accomplish. But they'll do it all in 1 line like this more often than not just to save a line. Okay? Now, that's a mentality that I don't agree with. And it's a common mentality of programmers. They think less lines of code is better. I've been doing this for a few minutes. Less lines of code is never actually better. Sometimes it allows you to keep something from being, horrifically verbose. And if you're writing this on a piece of paper, maybe that's a help. That's why sometimes you'll see in textbooks. I think we talked about this either this semester or last semester or both. You'll see them put that opening curly brace up on the same line as that guy. All right, to save a line because they're printing it on a piece of paper and it's easier to, you have a fixed amount of space. Okay, but I'm confident this guy will just keep scrolling, right? We can just keep going for a while, no big deal. So I like the curly braces one on top of another. It's not wrong to do it the other way. I don't care if you do it the other way. I'm kind of trying to share with you strategies to limit your number of errors because you're already dealing with enough errors, right? As you're writing your code, I doubt there's anybody in here who can say that it runs without errors the very first time. Pretty rare, right? You screw up somehow, okay? And most of you are running into issues where, have any of you seen the error yet in Java where it says there are too many errors, fix this one, fix these first? You seen that one yet? That exists. It's like, look, we found 10,000 errors in this. Okay. Basically, what you did is you pasted a Word document in there and tried to run it. Okay. Here's the ones we found so far. Deal with some of those and compile again. That error exists. It's a funny one. All right. So in any case, this is really something left over from C, the C programming days. So much older time period where maybe the mentality of trying to save physical space was a benefit or something like that. But I'd highly encourage you to, if you want this to be ++ count, you would print out count +1, and then you would do count ++ or ++ count. At that point, if it's on the same line, it doesn't matter which side you put the ++ on. That make sense? Okay, so split them into 2 lines so it's clear what you're trying to do. As soon as you don't want to do that, that probably means you understand how the ++ works. And then it's okay to do it on the same line because you know you're not going to confuse yourself. But at the same time, remember that somebody else might be reading your code. And the second you start putting little shortcuts in there like that, you might confuse somebody who's reading your code because they might not be completely comfortable with that little concept and might think that you're passing in a different value than you actually are. Kind of make sense? Okay. I'll never mark it wrong, but understand that I know what it means. So don't try to show off by putting it on the same line and then do it the wrong way, and then I do a little ha-ha on your test, okay, with a 0 next to it, an exclamation point. All right. So, any questions on the plus, plus, minus, minus stuff? All right, pretty common thing. Interesting trivia thing, though, is in our most modern language today, Swift. I say most modern from the perspective that it's the newest general purpose language. There's aspects of it I like, aspects of it that I just loathe. But, you know, in any case, they've actually gotten rid of count plus plus, like the idea of the plus plus operator. So now what they want to do is they want you to always say plus equals 1 or something like that. They underneath the hood, implementing this in a programming language, when you guys take 470 with me, which I would probably argue is our hardest class, we actually we build a programming language in there. So we create our own language and we learn what's happening behind the scenes in this. The class is a blast. I think it's a fun class, but it's hard. You start thinking about, if I were implementing this operator, how would that work? Okay, and the idea is that making that work from a parsing perspective is difficult because we have a variable name followed by no spaces, followed by a 2-character operator. So if you are reading this in, this is similar. This is kind of related to this last assignment where we're kind of working with string manipulation and stuff like that. If I want to figure out where my variable ends and where my operator begins, it's kind of a difficult problem to solve, especially if you have hundreds of lines of code. Kind of make sense? We have a visitor. Especially if you have hundreds of lines of code. So the Swift approach to this would have been that this guy is really an antiquated process. And because it's an antiquated process, let's go ahead and dump it and just go to our compound operators of plus equal, which is our shortcut of count is equal to count plus 1. This guy. All right, so if you want to use evidence for something, you might say that because Apple in their Swift language decided to remove the plus plus operator, it must not be good. Something like that. It's fine. Somebody else already solved the hard problem of making the parser for that. Realistically, it's because Swift does not require semicolons at the end of their line. So because they don't require semicolons at the end of their line, which is supposed to be a convenience for us, it makes their parsing more difficult. It's an Apple thing. You can also create variables with emojis in Swift. Isn't that stupid? Yeah, so I have this love-hate relationship with Swift. It's mostly hate, but I also write a lot of iPhone apps, so it's kind of a trade-off. I was a much bigger fan of the previous language, Objective-C, but what are you going to do? All right, so in any case, when you're looking at some code that you might find on Google or something like that, you might see them use little tricks like this because those are likely programmers that maybe have been around for a while or came from a C or a C++ background that are used to kind of combining these things on one line. What I'm telling you is very, very, very rarely is that actually beneficial to you. I would highly encourage you to separate things into 2 lines so that it's clear to you, as well as whoever else is reading your code, what it's doing. Make sense? All right. Same thing how I say that for your loops or your if statements, always have the opening and closing curly brace. Sometimes it's not required, but it's never going to hurt you. All right. So let's go back to this. So what we're going to do here, and here we'll adopt Swift's approach here. When we find a match right here, we'll go ahead and do our count plus equals 1. We found another occurrence of our sequence in the event that the pause from this guy right here did not return a -1. -1 means it wasn't found, right? All right. So whether this occurred or not, so this if statement, we only get inside this guy if this Boolean expression is true. What's a Boolean expression? Any value that boils down to a single value of true or false. So when this Boolean expression is true, we'll do this. If it's not, we skip it. And we're going to keep doing this do while loop, which is a loop that does something at least one time, right? As long as this Boolean expression is true. So as long as we previously found the sequence we were looking for from this line right here, we'll go ahead and spin up and search again. But understand that we're searching from a new starting point. All right? At the end of last class, remember we had this little comment here that says, finish this C bug on line 62. Okay? I'm thinking that this guy used to be line 62. I might have put something else in there, but whatever. So really the bug is here. What's the problem with our code as of right now? First time through, we're good. So here's your hint. Okay, let's assume we have 2 occurrences in our code of the sequence we're looking for. 2 occurrences in our input string of the sequence we're looking for. First time through, we find it because we're starting from bucket 0. And we find it at position pause, right? We go through, we decide, okay, we're good here, so we count it. We're good here. We found something, so let's go try again and find it again. We spin back up. We come to this line right here. What's wrong with that line the second time through? We're starting our search from position pause. Something like that. Let's say this is our string. So that's the string we entered in. ABC, BB, ABC. All right. So in our function there, this is our variable named S. Okay. Now, let's assume that we're searching for our ABC. That's our sequence that we read in. That's the guy we're looking for. Okay. So now we're going to pretend like we're index of. So when let's get our other variables in here. So we started off pause is equal to 0, right? And then we had count also is equal to 0 because we initially have not found any of those dudes yet, right? Okay. So when I call index of on this string, so this whole string here, passing it the thing I'm looking for along with the current value of pause. So the line I'm calling here is s dot index of sequence starting at position pause. And we're going to set pause equal to that guy. So we're going to overwrite the old value of pause with the position of sequence inside of s, starting our search from the current position in pause. Okay, so the very first time through, where do we find the first occurrence of ABC? What bucket in this string? 0. Okay, just happened actually here. Just so it's a little bit less boring, let's do an XYZ at the beginning of it. Just so we actually see pause. It doesn't change our logic here. But so now where do we find the first occurrence? 0, 1, 2, 3, right? So the first A is at bucket 3, which is the beginning of our sequence ABC, which is the guy we're looking for. All right, so after the very first time, pause will be equal to 3, correct? Then we ask that question. So back in our code here, we ask the question, if pause is not equal to -1, is pause something other than -1 right now? Yeah, it's a 3. Pause is a 3. So that's something other than -1. It is true that the current value of pause, which is 3, is not equivalent to -1. Therefore, we'll increment count. Count becomes 1 larger than it used to be. Okay? So there's count is equal to 1. Found it. So we hit the end of our loop. While pause is not equal to -1, we just confirm that it is true that pause is not equal to -1. It's currently equal to 3 in our example. we'll spin back up and do this again. This is a line that's giving us our error, our bug. Okay? So here's the current state of things. What will the value of pause be after we call that index of method? I'm looking for the sequence ABC starting at position 3. So I'm going to start my search right there. Where's the first place I find ABC? Right there. I'm going to find the same thing over and over and over and over and over again, right? This is an infinite loop. Because I'm never actually moving pause. Okay? I'm not saying, okay, I found it here. Let's start looking from the next place in our string. That makes sense? So with that in mind, how can we modify this code to fix that problem? What do we need to happen? We really need, at least our second time through, we need pause to be 1 larger than it used to be. So we really want to increment pause each time, right? Okay. Could I start pause off at -1 there? Kind of prime it to be 1 smaller than it used to be. And then when I search for pause in here, we'll set it to pause +1. -1 plus 1 is 0, so it'll be our 0 the first time through. Then we found it at bucket 3. We count it. 3 is not equal to -1. We spin back up. Then we say set pause equal to searching for our sequence starting at position 4. Kick it ahead 1 to find that position. That way we're starting our search after the last place we found it. Make sense? All right, so do our search again. So now we're starting our search right. Starting our search right there. Where's the next occurrence of ABC? That's 4, 5, 6, 7, 8. Right? It'd be bucket 8. So pause will be equal to 8. Then we ask the question. Here's our if statement here. Is 8 not equal to -1? Is that a true statement? Is it true that 8 and -1 are different values? Yep, that's true. So count become 1 bigger than it used to be. So there's our count is 2. We hit the end of our loop. Is it true that 8 and -1 are different? Yep. Spin back up. We're going to search in pause for our, well, search in S for our sequence starting at position 9. So I'll start my search right there. And where's the first occurrence from that starting point of our sequence ABC? It'll be a -1. It's not found, right? So our little trick with index of is that it gives us a -1 when it doesn't find it. So we found our 2 occurrences. Count is currently equal to 2. We did our last search. Pause will become a -1 there, right? Because it did not find it that last time through. So what are we going to do? We'll get to our question. Is -1 a different number than -1? Oh, that's the same number. So we will not increment count. Count is still 2. Then we'll hit the end of our loop. We'll ask the Boolean expression. Kind of an important thing. A lot of times what beginning programmers miss is they have in their head what the logic should do or will do, and they assume it breaks out 1 time earlier than it actually does. Okay? You still have to ask the question. You still have to allow the Boolean expression to fail. Make sense? So we're asking the question, is a -1 a different number than a -1? Is it true that -1 is not equal to -1? That is not a true statement. That's false, right? Those are the same number. Therefore, this Boolean expression is false. We only keep looping as long as that Boolean expression remains true. So we fall past it to right here. Make sense? All right, so we're sitting there, and if we look at our example here, count holds the current number of occurrences of our sequence in our string. Okay, so after that while loop is done, what do? Well, we've advertised that we're going to return nothing. Why did we decide that our return type of find text should be void? When do we have the return type be something other than void? Or if you want to answer the opposite question, when do we use void as our return type? So the last couple of classes we've been talking about these trade-offs, and one of them is having kind of self-contained code, right? And we wanted this guy to be completely self-contained. We passed in the string we want him to do some searching on, right? But he does his questioning for what's the sequence you want to search for. He does all of his logic. And is anybody else going to actually use that value in our logic? Is anybody else going to actually use the value 2 by our example? Or is that something we just want to spit out to the screen? Yeah, we're just displaying it to the user like, hey, I found 2 of these. Good for you, right? So we're returning void here because we don't actually want to return that 2. We're just going to display it. We're going to print it. And when this method's done, we're going to forget about that value. We'll calculate it again next time we call it. Okay? So when we get to right here, we know our value. So we can say count holds the number of occurrences. Occurrences 2 or 7 R's? How many R's are in that? There we go. Nailed it. All right, so we can go ahead and do a system.out.println count. And that'll print out the number of occurrences we found in there. Make sense? Okay. And there's other ways we could have pulled that off. But I want to start by showing you our trick that I alluded to last class. And we're going to do it on one of our other questions here. And actually, let's go ahead and why don't we test this real quick. So we'll use our test string right here. We'll go ahead and run this guy, enter our sample text. All right, and then we want to do some finding of text, right? So we'll do F. Did we do the if statement for this guy yet? Nope, we didn't. All right, so we go up to our logic here. Else if they enter in an F. So this guy processes the option returned by our show menu. They entered in an F. We'll do driver dot find text, passing it my text. Okay. Now it should do what we wanted it to do. Oh. I guess we could have used that as our input string. All right, we'll go ahead and find some text. What sequence should I look for? We'll type in ABC. I'm not getting an output print. What does that mean? What should that tell you right off the bat if it's not printing something out based on what we did here? So here's our find text. If I'm not seeing the value of count printed there, what does that mean? And if we want to expand on this, we can say the number of occurrences is that, just to label it. If I'm never seeing this, what does that tell me? Is it telling me that I'm never escaping this? I'm trapped. I'm in an infinite loop. Something is keeping me from escaping that. Okay? What could keep me from escaping that? What are the scenarios? Well, the only way I escape this while loop is when what's true. When pause is not equal to -1. That's when I finally get out of that guy, right? I finally get out of this loop when I get a -1 in pause. So this means that this guy is never returning a -1 in our current string. We want to know why, right? So our old school way of doing this would be what? Maybe we go in here and we do a print. Let's just see what the value of pause is. All right, so we're going to, thing we need to be careful of here is we are in an infinite loop, so we're going to see a lot of crap printed to the screen. So we're going to introduce the debugger here in a minute. Okay, so we'll go ahead and run this again. We'll put on our sample text. We'll search again. I'm getting 11 over and over and over again. Well, we'll leave that cooking for a second. This is bucket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's off the end of the string. So at some point, let's kill this here. I'm saying I want to search for my sequence starting at position 12. Now what can you tell me about position 12 as it relates to our example string we're working with here? We saw that my example string here does not have a bucket 12. We've experienced that, right? We're off the end of that string. So we want to kind of see where things are going south in our search. Now we could start throwing print statements all over the code and things like that, and things will get messy. But right off the bat here, we're seeing that, well, this is a little bit hard to follow. If I run this guy, I do my search, like, whoa, wait a minute. I just put an F in. Just put an F in. Did you ever see the question, what sequence should I look for? Did we see that question? Let's run it again. Oh, sorry. There's that. Choose my option. There's my F. Ah, popped up just for a second. Just for a second at the top there. So wait a minute. I never even got to put in what sequence I was searching for. Okay. Let's kill this here. Now we did see that pop up, right? If you looked really careful, that guy popped up just at the very beginning. And then we saw the wall of 11s following it, right? Okay. We have, eventually Eclipse would have crashed when our terminal there would have run out of space. This was the dude we were looking for. Now, what I'm going to do here, instead of printing out pause, let's print out sequence. And just so we can see something here, I'm going to do sequence colon space that guy. We want to see what it thinks sequence is. We'll be able to read this because it's going to be printing this over and over and over again. Okay? Now, are we starting to see this is going to be fairly tedious to keep putting print statements all over the place? Go ahead and run this. Put in our sample text again. Put in our F. Now I'm going to press enter. What do we see after sequence? We don't see anything. Do we suspect something's probably there? Maybe a carriage return? Maybe the last thing we hit, which was enter? Remember last class, we were talking about whether or not to use next or next line? my sample text. There's my F. Oh, thank you. It's waiting on me. There's my ABC. And there's my number of occurrences. It's 2. Now, what do you suspect was going on? When I had next line in here, what was it getting? When we built our input, which is our scanner up here, we originally built that guy. We built it with our system.in input stream, which is our keyboard, right? And next line reads the very next thing it can read up to a carriage return. This is pretty related to our problem of our index of problem we're running into, right? Where we want to make sure we don't start our search at the place we ran into last. That's why we're adding 1 to pause, so that we keep moving our way down that string. Now, when I put in F and I pressed enter, was there not a carriage return left on the end of that line? Last thing I did was type in a carriage return, right? That's what enter did. Now, when we did our menu, let's go down to our menu function here. I said input.next, not next line. So I used next to grab the next string, leaving me on that current line. So it removed the string from that line. In our case, it removed the string F, right? And then got character at bucket 0, char at 0 from the string F, which is still an F, just as F as a char. But it didn't get the carriage return, did it? I didn't want the carriage return. I wanted that string to be of length 1, single F, not of length 2 with an F and an imaginary carriage return. So next took me up to, but not including that carriage return. Now when I did next line, what next line says is it says, grab all the characters you can until you bump into a carriage return. It just so happens I bumped into a carriage return pretty quick. When I use next, next automatically shifts our character pointer ahead 1. And begins the search after the last entry. That make sense? So as we kind of walk through that, it was important. We did some print statements there to kind of show us where things were going south and stuff like that. But it took some investigation, Sherlock Holmes style, right, to kind of figure out where the error may have been. Okay? Now, we put some strategic print statements in there, and those strategic print statements are okay on a small little scale like this. I wouldn't say it's necessarily a bad idea here, but we can go ahead and take this opportunity to pretend like our error is still there. So let's go ahead and put our next line back in. Well, I put it back in already because we wanted to see the value of sequence. So I'm going to go ahead and take our prints out of here. Okay. Now, I want to see how this function is working. So I'm really interested in what's happening in here, and I want to follow it 1 line at a time. So we kind of did this over here, right? We really traced our program by hand over here, didn't we? We kind of see what it was doing, and the logic seemed like it was going to make sense, except we took for granted how we got this guy. Built into most IDEs, integrated development environments, whether it's a fancy one like this that's all colorful and has, command completion and stuff like that, or an old school text editor like Emacs or something like that, they usually have a built-in thing called a debugger. Okay, and a debugger allows us to put a breakpoint someplace, which is a place where we want our program to stop. When we run our program, it runs automatically up to that point, and then it breaks. It pauses our program. And then it lets us step through our program 1 line at a time or jump over things, whatever it is. We'll see a couple of the things we can do. And it shows us the current state of our collection of variables as we're making each step. So we don't have to print a bunch of crap out. It just says, hey, you're probably interested in your variables. Let me show you what's going on. Make sense? So what we're going to do is we're going to come over here. I'm going to go just inside of our function. So you don't want to do it here because this is, your code actually never stops at the function call. Your code stops inside the first line in the scope. So let's see, did that guy put the breakpoint? So I'll right click, I think double clicking will do it too, but I'll right click here, just out in the margin, and I'm going to do toggle breakpoint. Right, and that put a little breakpoint there. You can also just double click there, and that'll put a little breakpoint. Okay, so now before I do anything else, I'm going to go ahead and I'm going to run this guy. Now, an important thing you might run into, a mistake, so I'll go ahead and mimic the mistake that many of you will potentially make. I'm going to go ahead and hit play like I usually do. Enter my sample text, there it is, put an F. What, it's still going? We're back in our infinite loop. I stopped printing out our sequence there, right? I thought I told you it was going to break. Let me walk through it line by line. We hit the normal play button that we usually hit. What we need to do is hit the little bug-looking dude next to it. That's the debugger. All right? So you highlight over it. It'll say debug driver or something like that, blah, blah, blah. So I'm going to go ahead and hit that guy. We'll enter our sample text. We'll type in F. Now it switches into our debug view. All right? And notice it's sitting there right on the line where we put our breakpoint, waiting for us to tell it what to do next. Make sense? Now, up top here, well, first of all, up here, it shows us our current variables. So in the scope we are currently looking at, okay, how would you define scope? We had a quiz or something. I said, tell me what the word scope means as it relates to variables. What would you say? Such an active group. I could sit here all day. Go ahead.
Where the variable lives and dies, or like where you can actually access it or change it.
Okay. So where a variable lives and dies, where we have access to it, you know, the miniature world where that variable lives. All right. So in this case, we are inside the scope called find text. Well, that we've artificially named find text. And I've said that a majority of the time we can identify scopes when we see opening and closing curly braces. That's not always the case, but it is the case here. All methods come with their own scope. All right, so our scope starts here, and our very first member of that scope are going to be the values that were part of the parameter list of that method. So we have one dude here named S. So if we look up here, and the font might be a little small, but we have S here, and here's the current value of S. Make sense? So we're seeing the value that we actually passed into this function. Pretty similar to what we drew here. Now we have some tools up here. I usually prefer when they're down here and some other things, but whatever. So this guy, this first one, so there are the guys that look like little arrows. All right. First guy here on the left says step into. So as we're going through here, if we are making a call to another method, probably one of our methods is when this would be most helpful, we might step into that method, which kind of removes control from where we currently are in our program, because we might want to walk through that method's logic and see what's going on. All right, but we didn't write any other methods that this guy calls. Everything's self-contained, so we probably aren't going to use that guy here. This next one here is called step over. This is probably our go-to move most of the time you use a debugger. Okay? We want to walk through it one line at a time, stepping over this line, stepping over this line, stepping over this line, and look at how our variables change, how they get modified. Make sense? All right, so we'll go ahead and we'll step over this for, well, here, let me just show you the last guy real quick. Okay, this guy's step return. This allows you, this reverses your step into. So if you step into a method, you can get out of that method, returning control where you left off by stepping out of it. Step return. Okay? But like I said, I mean, I'm making up the percentage, but let's say 95% of the time, you're going to do step overs. You want to walk your code one line at a time and see where things zig when they should have zagged. All right? So we'll go ahead and step over there. And notice that it stepped over this line, and we saw a little output here. Okay? Now we're going to try to step over this line. What do we expect to happen when we try to step over this line? A couple classes ago, we talked about blocking versus non-blocking calls. Driver.input.next line, whether we use next line or next, they act the same. Blocks. What does it mean for a call to block? Go ahead. Yeah, in this case, until a person inputs something, but blocking in general would say program won't go on until this guy can finish, right? And next line isn't going to finish until it sees a carriage return. Just so happens a carriage return happens pretty quickly here, right? Because of the nature of our input. We're still using the next line, so we have that guy sitting right there. So this is going to be our first evidence that this might be where our problem is, right? So I'm going to go ahead and I'm going to try to step over this line. So where that green is, this guy right now kind of looks blue there, but it's green on my screen, I promise. Okay, where this guy is the line we're currently on. I'm going to try to step over that line. And because I know this blocks, I'm expecting to have to type in an input down here just like I did with the F. So I'll go ahead and step over this guy. Ah, wait a minute. Where was my opportunity to write something in there? Okay, well, hold on a second. I was trying to read that into a variable called sequence. Notice we now have sequence up here. And sequence looks like the empty string. Now, why would it be the empty string instead of the carriage return? Because next line reads everything up to but not including the carriage return. It gets us the string. In this case, we had no string in front of our carriage return. The empty string, the string with length 0. Okay? But we didn't burn past it. Okay, so next line didn't hop that carriage return and say, let's pick up where we left off last time, which means it's waiting for a carriage return, which means it's waiting for us to type some more crap in and then press enter. Okay? So right off the bat here, we're going to say, oh, okay. Sequence definitely doesn't have in it what I want it to have in it. It has nothing in it. And I had nothing to do with it. Well, I had a little something to do with it, but not when I thought I was going to have something to do with it. So we're going to stop right there and we can say, oh, well, I want to now focus on that line. That line did not work the way I thought it should work. So now we've walked through our code and we've landed on the line where we perceive the problem is, right? Now we can focus in our problem solving right there and say, what's wrong with that? So we go in and we'll make a little change. I'll go ahead and stop the debugger. And, we fumble around. We end up switching that guy to next. So the other version that we talked about. We'll go ahead and run the debugger again. And let's see if we do a little better this time. You might be inclined to say, well, I thought my logic was good, so let's just try running it normally first. But just so we can see how the rest of the debugger works, we'll go ahead and swing through this. So it's asking for our sample text, so we'll go ahead and paste it in there. I'm running in the debugger. Notice that we're still in the debugger view here. The first time you launch the debugger, it has to load this view, but now we're working within that view. All right, so I want to go ahead and I want to replace, or I want to find text. I'll do my F. Ah, this time the guy's waiting on me. Okay, so, oh, actually, he's not waiting on us yet. So we got to do our step over. Now, when I try to step over that line, he didn't just jump to the next line. He's blocking. All right, this line is not going to finish till I type something. So I'll go in and I'll do my ABC. Ah, now I drop to the next line and notice that sequence up here, this variable, has the value that I intended in it. Make sense? So I'm seeing everything in my scope currently, everything I care about, everything I might care about, let's say. When we start getting into writing our own objects, we'll see we actually have a more global scope. So we'll be able to see stuff that are global variables to our objects. So we'll walk through this. We're about to introduce a pause and a count. So as we step over those lines, you notice that pause shows up there, and count shows up there, just like we spent some time in here putting various text boxes with some variable names in it. And we could walk through our logic. And so the very first thing we're going to do is we're going to look in S for the index of, and notice if I highlight over S, it'll tell us the value of it. Highlight over sequence, it'll tell us the value of that. Hover over pause, it'll tell us the value of that. So you don't always have to go up here and look. It is up there, but we can work with it down here. We're expecting to get what, a 4 or was it a 3? A 3 the very first time, right? So we'll jump over pause there. Notice that pause is currently equal to 3. I can hover there and see my 3 as well. Everything seems all right. Okay, so we do our count plus equals 1. We can keep walking through this one line at a time, yada, yada, yada. All right, so we'll experience this, that we spin back up. We get our second pause. Pause is now equal to 8, as we expected. Step again, spin back up. Now, notice that pause is equal to a -1, which means that we will fail this if statement. So when I step over this line, I'm going to expect it to not go in there. Instead, I'll expect it to drop here. So I'll step over. We're going to ask our last question again. I'm not going to expect it to spin back up because this is going to fail. I'm going to expect it to drop down. Loop is over. I'll do my printing of my final answer, which is stored inside of count, which is a 2. Step over. There's my answer. And when I'm ready to let the program just keep chugging along, I can go ahead and, let's say we're still testing. There's a little play button here that just says resume. So that says pick up from here, stop letting me walk through it one line at a time. What's nice about this is you can actually set multiple breakpoints. Okay? All right. So, homework assignment, I'm going to give you and we're right at the end here, so I'll put it up on online. I'm going to give you a reading assignment with a question that will be Tuesday's quiz. So expect a quiz on Tuesday because we haven't gotten into the objects enough to give you the first programming assignment there. All right, but I'll give you the next reading. All right, I will see everybody on Tuesday.